setting the scene, Gordon and Chris. That's certainly, I hope we're all on the same page regarding the importance of resilience, but it's very much front and centre in the industry at the moment, and it's been front and centre in Cloudsoft's mind for our lifetime, actually. We are, by trade, we are toolsmiths, and we've been helping to build sharp tools for technical people in the distributed systems arena to use technology better and more effectively, which has culminated with AMP, our application management platform. Now, I don't want this to be a sales pitch. I'd like to introduce you to our kind of philosophical thinking which underpins our product development. But I think the really valuable part of this session is not going to be me talking, but it's going to be kind of we talking as a group. So I'd quite like to get to the Q&A session, because I'd love to hear what other people on the call think about this whole topic. But I'll run you through the Cloudsoft mindset around application resiliency and the tooling that we as toolsmiths have put together to help in this arena. So I am a technical guy, as Chris has said. I'm a principal engineer with 25 years of experience under my belt in the Scottish software development scene. I literally have a grey beard, so I am a grey beard. I will try and keep. I'll try and resist the temptation to stray into deep technical details. But again, if people would like me to go into technical detail, I'm more than happy to talk tech with folk on the call. So feel free to interrupt or interject with questions, but obviously there will be a lengthy opportunity at the end to really get into some hopefully good discussions. So I was reflecting recently that Mark Andreessen, the famous Silicon Valley VC, he very famously opined that software is eating the world. And I was shocked to note that was 10 years ago. That was back in 2011 when his Software is Eating the World article appeared in, I think, the Wall Street Journal. And since then, in the decades since, of course, it's well and truly eaten the world and came back for seconds as well. And software now underpins every aspect of virtually every business. Particularly in the financial services and banking arena, but not exclusively. I mean, everything seems to run on software. And when software fails, it's not just a failure of software, it's also a failure usually of some business process as well. So in the 10 years since Mark Andreessen made his famous observation, I think the situation has only exacerbated. I think we've become increasingly dependent on software and technology in general because it makes us more efficient. There's an increasing amount of specialization and interconnectedness in the systems that we rely on day to day as business people and as people that have customers to whom we serve with our business solutions and our technology solutions. And I think the range of complexity is now, an order of magnitude more complex than it was when Mark made his observation 10 years ago. The cost of failure has also gone up. Regulators are paying a lot of attention to failures in the financial services industry, in the banking industry. The last thing any of us want is for our business to appear on the front page of the FT because of a system failure, or worse, on the front page of the tabloids, the front page of the Daily Mail, which of course famously happened in 2018 to a bank in the wake of some truly catastrophic downtime that was very disruptive to their customers. So not only are failures increasingly costly in terms of regulatory scrutiny and fines, but they're also increasingly visible, which of course has a cost attached as well in terms of reputational damage and just general tarnishing our good name. The old approach to technology used to be that we would just be very conservative about change management. We would maybe only release updates once a year. And this conservatism was the way that we would manage risk. We would treat our infrastructure as very carefully, much loved pets. And we would strive to make sure that every component in the stack was rock solid and stable to the best of our ability. And we would be extremely cautious and conservative around change management. But that's no longer an option because in the new world of cloud and internet services, the incumbents are being disrupted by the upstarts who are able to move with great agility. And businesses that cannot adapt to the fast changing business climate quickly find themselves losing customers and ultimately no longer in business. So technological conservatism isn't an option anymore. Going slowly and being very risk averse to the detriment of our business agility and our pace of change is not sustainable as a business strategy anymore, which leaves firms with this particularly challenging balancing act to do between releasing features quickly and adapting to the changing landscape, but also releasing software and building systems that are reliable and resilient for the reasons we mentioned. So this issue of operational resilience of firms, and in particular digital operational resilience, has really bubbled up. You know, in the wake of the financial crash of 2008, 2009, the regulators really sat up and started to really explicitly address this problem of the kind of the brittleness of the financial system. So operational resilience is the phrase du jour, and you know the EU is pushing Digital Operational Resilience Act as legislation through the various regulators and legislative bodies of the EU to really bring this, you know, into sharp focus in everyone's mind. But for the business to be operationally resilient, it's no longer just about, you know, levels of liquidity and key staff and indemnity insurance. Because software ate the world, the resilience of a firm is now tied more than ever to the availability of key software systems which are delivering key business functionality. So because of this incredible reliance, the business is now more reliant than ever on working software systems. There's a requirement for the whole technology stack to be resilient so that those applications are available, so that the business is operationally resilient. But of course, this presents a challenge, and you know the House of Cards image is quite apt, because technology, those of us who are familiar with technology and have been working in this space for a while, we know that technology is failing all the time. It's no longer acceptable to think that we will just install software on a system and we'll just buy expensive hardware and we'll buy expensive network cards and we'll just set it running and we'll never have to intervene, because there's always disks fill up, processes leak memory, networks occasionally become unreachable and power supplies fail, and there's all sorts of constantly churning pieces of the infrastructure that are falling over in myriad diverse ways. And we have to accept that failure, particularly as we outsource more and more of our IT to third-party infrastructure providers or cloud providers, that the law of large numbers dictates that a certain proportion of that estate is going to be failing. And in a sense, it's unpredictable what's going to fail and when, but the fact that something will be failing virtually all the time is very predictable, and we should face up to that. So of course, there's a crucial role to be played by, you know, the application designers, the solution architects, and the system gurus who, I mean, entire libraries have been written on system architecture and resiliency and fault tolerance and high availability. So there's a lot of knowledge, technical knowledge, which can be brought to bear in how we design these systems to be fault tolerant. But there's also an operational piece which, you know, in my experience, is often overlooked. It's all very well having systems which can tolerate failure, but they have to still be managed in a continual way. There's a constant set of management operations which are required to keep the system as a whole healthy. And I think the trick is to architect the system in a way that small failures don't blow up to create this mushroom cloud. But then we have to be able to recover from those small failures in order for the system to return to its stable baseline, and that requires management. And our view at CloudSoft is that management that requires people is not scalable and will not help you meet SLAs. Now, we love people, we're not anti-human in any way, but really the way you achieve strong operational resilience in the IT realm is to automate the hell out of everything, particularly the detection and recovery from failures, which are inevitable. Just to give you an idea of what I mean by scale and strong SLAs, if you are striving to achieve 5 nines of uptime, so 99.999% uptime, that doesn't sound difficult, 5 nines, it's only 5 nines. But that gives you a budget of barely 5 minutes of downtime every year. So think about that. Think about your incident response process in your organization. If there's a failure of some component which leads to a downtime of the system, it leads to a failure of availability of a system, how long does it take you to get an engineer paged, potentially in the middle of the night, woken up, to get himself or herself sufficiently awake and in front of a computer, management tools to diagnose the problem, let alone resolve it? I think you've blown your 5 minutes. In fact, I'm sure if it's me that's getting paged, I'm a blunt tool if I'm just awake, and it will take me 5 minutes to wake up. So there we go. We've blown the entire downtime budget just by having a human in the loop. So we have to remove humans from the loop wherever possible. And the CloudSoft approach to that is to have management tooling which isn't just automated, but it's automated in a way which is very aware of the structure of the workload under management. And I'll show you what that means. I'll show you what that means in terms of kind of the theory behind it. And I won't go into a real-time demo just in the interest of time, but I've kind of got some screenshots of our tooling solution, our management platform, to kind of show you what that means in practice as well. Our solution we call AMP, which is an application management platform. It's actually also a bit of an overloaded term, which is infuriatingly difficult to Google because of other products in the market called AMP, but we'll not go into that. And AMP acts as CloudSoft AMP acts as a software control plane, which is continually supervising and taking action, actively managing the workloads, the critical business applications that it is responsible for. So we've introduced automation that covers the entire software lifecycle. So not just deployment time automation, but in-life management as well. And the approach we've taken is to model all the components of the system, every tier, every component of that software stack in the form of blueprints. So blueprints are now code artifacts which describe each component of an application in a composable way, so you can treat them like Lego bricks to assemble a description of the overall system. These descriptions, these codified blueprints, can generally be deployed to any target infrastructure, whether that's bare metal servers or hypervisor platforms, container platforms like OpenShift or Kubernetes, and increasingly public cloud platforms. So the expertise we've built up over the years in building tools that can talk to cloud APIs has really put us in good stead to be able to deliver multi-cloud, multi-platform application tooling. And the whole point of AMP is that there's automation built in. That automation can be attached to any level of the technical hierarchy, and I'll show you what that means in practice. But this is what we mean by AMP understanding the application context. It understands how resources are linked together into an application, which I think is crucial to understanding the business value of that workload and the business impact of any outages and downtime, which should inform our budget for resiliency and management tooling. But also, management doesn't just stop once you've deployed the app. This is where, there are some excellent tools which we integrate with Terraform and CloudFormation and Azure Resource Manager. These are excellent tools. Terraform, for instance, wonderful tool, but its responsibilities stop at deployment time, whereas AMP's responsibilities keep on going through all the change control, through all the auto scaling, scale out and scale in events, through upgrade events, through recovery from failure management and the changes that are needed in life post deployment. Here's a slide I don't expect anyone to read. This is an infographic that should really be projected onto the side of a building. Far too many words, but I just want to call this out. This is part of a holistic philosophy that we have. Applications are at the center of the world because software at the world. And this is the heart of the CloudSoft philosophy. Applications are what deliver business value, not infrastructure. And as technologists, we sometimes forget that technology doesn't exist as an end in itself. It exists to host these applications, which in turn exist to serve the business and to drive revenue and to satisfy the business's customers. But surrounding the applications, there's a whole lot of stuff that has come to be, that has come into existence over the years. So we've now got, well, you can see the categories around the outside. We have to monitor what we deploy. So we have a plethora of monitoring tools, and we have CI/CD tools, and we have infrastructure as code tools, and we have configuration management tools, and we have platforms, and we have clouds, and we have the whole ecosystem around technology is vast and complex. And there are a number of point solutions, very, very good tools that exist as point solutions in this kind of constellation of responsibilities. But really, you have to think about the applications as being right at the center of it. And coordinating all these different technical responsibilities across the whole landscape into something specific to the context of an application can be challenging, which is why AMP came in. So AMP is kind of a platform and a tool that wraps up all these different responsibilities, but keeps applications very much at the center of its world. So I'm going to move on from this slide before I have a heart attack, because there's just far too many words. Once you start thinking seriously about resiliency, and once you're having proper conversations at the business level about what resiliency is and what it entails and how it impacts key business metrics and how it impinges upon the technology landscape across the business, you then start to regard resiliency itself as a key capability of the business. And once you start thinking in terms of, well, it's a key capability, it's natural then to think about a capability maturity model. And we've started to write some literature on this subject, and we've published an ebook which really focuses on resiliency as a key business capability, and it introduces this idea of a capability maturity model for resiliency. With all capability maturity models, the idea is not just to rush to the end and to reach the desired utopian end goal of resiliency level, whatever it is, capability level 4 or capability level 5, whatever model you're using. But the idea is to really kind of surface these notions that you can assess where you are on this maturity model, and you can also decide where, as an organization, based on your organization's vision and mission and outlook, if you will, where you ought to be. Where's the right level of maturity for you to sit, and then how do you get there? Which stepping stones do you have to cross? Do you have to use to cross that gap? So I'd encourage you to download the ebook. I'll provide a link at the end of some resources that we've made available. The ebook is one of them. And I really hope this kind of drives the conversation within your organization, but also within this kind of wider community around what resiliency means. So what does it mean in practice? What have we actually built as toolsmiths at Cloudsoft? What have we actually built? Well, we've built a product called AMP, the Application Management Platform. And I'll show screenshots instead of a demo, but if anyone would like me to go deeper, or if anyone would like a demo, then please reach out to me. I love talking about technology, and I love talking about our technology and how it can help you with your technology. But AMP is a software control plane which surfaces a lot of runtime information about all the components of a system. And it does that by using, as I hinted at before, a deployable model of the application, which is then kept alive by ongoing management by the platform. So we can see here, we have a pretty simple 3-tier application, but it's a productionized one with a load balanced front end and a replicated data tier in the back end. So this is actually a real system that we deploy and manage for one of our customers. So we can see that AMP is interested not just in the fact that there's an application called AgriNow, but it's intimately familiar with the internal composition of that, and it knows actually down to the level of which software processes are running to support this application. AMP is able to take care of all the complex asynchronous task execution that will happen across a whole distributed estate of infrastructure in order to stand up every one of those software components and specialize the kind of the raw stem cells, if you like, of bare metal infrastructure or a plain vanilla OS that has been deployed in a cloud. That example was deployed into AWS, but it could just as easily have been deployed in Azure or onto a container platform or on-prem. And AMP takes care of all the nitty-gritty asynchronous stuff to download software artifacts and customize them for our specific use case. It makes sure that little trick we have to remember to do to patch a kernel parameter or change a ulimit or run as a specific user with certain permissions, all that is codified into the blueprint because, one, it's best practice, so we don't want to forget to do it, and two, it means that anywhere we deploy that component, those best practices are applied. So AMP comes with a a whole catalog of composable component models, but we expect our users, our customers to contribute their own. We're Java at the heart, but we support a whole bunch of open standards to make it easy, very easy to contribute extensions, whether that's custom component types or custom policy types, or whatever you have. Everything we have is composable Lego bricks, so you can start from scratch, or you can start from an existing component and tailor it in some way to add some context-specific monitoring, insight, or management responsibilities. We also, because we have this rich catalog of reusable Lego bricks, we've got the toy box, and it's possible to drag and drop graphically these components from the palette, from the toolkit, into a description of your system. But under the hood, it's all plain text YAML. We can treat it as infrastructure as code. It's all version controlled and composable. So with a little bit of familiarity, we can look at the YAML and understand what it's doing. YAML is a plain text markup language, which you saw on the previous screen. So we aim to make this, we aim to kind of cut the Gordian knot of complexity by encapsulating best practice, so a subject matter expert can contribute a small component to the catalog, and then system builders can then assemble those best practice components into a system. We also have policy-driven automation. So here's an example. I ran this morning, and we can see we have the usual kind of dynamic in-life management that people who are familiar with cloud are used to seeing. So here we have reactive management in the form of auto scaling, which will help, ensure that our front-end resources are not swamped by an increase in load. So we can be reactive, and these policies are extremely extensible, customizable. You can contribute your own. You can tie the autoscaler to any of the metrics that are bubbling out of the runtime components. And crucially, you can attach AMP policies to an individual component or to a tier or to the overall application. So we can do it reactively. So here we do autoscaling in response to load. We can also do it proactively. So here, this would not be done for resiliency. This might be done for cost optimization, whereby we can start up and shut down, pause and resume resources according to when they're needed by the business. So in this example, we've actually got a test environment, a user acceptance test environment, which isn't needed 24 hours a day. So just by shutting it down for 12 hours a day and shutting it off over the weekend, we can save more than 50% of the cost of running this in the cloud. So again, this is just the other side of the automation coin. We can do automation reactively in response to all the runtime information, or we can do it proactively based on context-specific information we have about a specific workload. And again, policies can be attached to individual components, or in this case, to an entire tier. So the entire backend tier of shared services will be suspended and resumed according to a schedule. And the same thing can happen with the target infrastructure to which we're going to deploy our components. So we can attach, this post-trade example is deployed in Azure. The Agri example is deployed in AWS, but there's nothing to stop us deploying part of a workload in one cloud and part in another, or part on-prem and part in the cloud or in a container platform. So again, decoupling the application from the infrastructure on which it runs is useful when we're composing the system, but make no mistake, AMP is acutely aware of the entire stack. AMP is able to understand the underlying infrastructure and make management decisions in the application realm and in the infrastructure realm as well. So again, I hope now that I show this horrendous diagram once more, not projected on the side of a building, but I hope that's kind of drawn into sharp focus, kind of what some of these dimensions of application management actually mean in the context of the tool itself. I would love to give a demo to anyone who would like a demo. We have some resources on our website around the topics of resiliency and downtime, and we have republished a Gartner report from a couple of years ago, which has an interesting take on the true cost of downtime is not what many organizations think it is, and it's worth a rethink of what downtime means and what it costs, and crucially when it starts to cost a lot, because it's not a linear relationship. But also, as I mentioned before, we're publishing kind of thought leadership pieces in the resiliency space, and we'd urge you to to have a look at our website, cloudsoft.io, and look at some of the resources that we've made available, and obviously look at our software as well, if that is something that you think would benefit your organization. Please do link in with me if you want to continue the chat. I love to talk about tech, and I would love to hear from you. I'll stop talking now. I'll hand back to the moderators, and hopefully they can facilitate some Q&A. But thank you very much.
Well, thanks a lot for that answer. I love the kilt diagram.
Aye, puts them on.
Incredibly appropriate and very Scottish. But yeah, no, I think that it was a really interesting view, and again, I think it's a good development of what people have been trying to do with kind of homegrown ways of managing their application estate, and it breaks down the silos so well that and throwing in the life cycle as well is very handy. So I think probably every organisation I've ever worked for, they've kind of missed out on the impact of change control on ITDR, and also the change in business processes, the change in things going global, or simply just mergers and acquisitions. Things just fall into the cracks, and the DRBC people are always running around madly, sort of screaming, "You need to wake up and fix this, otherwise, everything is going to go horribly wrong." Or you could even end up recovering something inappropriately and then ending up with an out of sync situation 3 days down the line. So
that's actually a good point, Gordon. We work with one of the world's largest investment banks in New Jersey. Not yet able to publicly reference them as a case study, but a very big deal for us at Cloudsoft. And they're using AMP as part of their resiliency, their unified resiliency platform. And yes, they had runbooks, they had fastidiously documented processes, but what they found was that their existing runbooks and their existing point solutions around automation, they often didn't result in recovery that worked, which is of course a catastrophe. If your recovery doesn't work, then you tend to discover that at the worst possible time.
Exactly. Yeah.
So they reached for some Cloudsoft fueled application solutions based around AMP. Yeah, and the quality of the recovery obviously went through the roof. They reduced human involvement. They reduced that by about 95% improvement on recovery times, because we've removed humans from the loop, and we've introduced a greater degree of consistency so that we can actually test the resiliency automation in staging. We can test it. We don't have to wait for everything to hit the fan in production. We can test this automation, and now it's done consistently every time, because that's how you do it. You automate.
Which is also